Hello everyone and welcome back to the Ionic Compounds lecture series. Let's continue with transition metals with variable charge. Remembering that the transition metals are in the middle portion of the periodic table. Also, these over here are called the inner transition metals. And these metals are special in that some of them can have more than one charge. And also, from the periodic table, we're not able to tell that charge like we are for the main group elements. So, let's write those things up on the board, that the group number does not tell the charge, like it did before for the main group elements. The way that we tell in the name which charge the transition metal can have is by using a Roman numeral in parentheses. All right, so let me show you the chart that you will always receive on quizzes and exams to figure out which transition metals can and do have a variable charge. So this is the chart right here, showing from left to right. Chromium, up in group 6B, can either have a 2+ or a 3+ charge. Manganese is a transition metal, but it can only have one charge. But it's included in there because it is common. Iron can have either a 2+ or a 3+ charge. Cobalt can have a 2+ charge. Nickel, 2+. Zinc, 2+. And then silver and cadmium down below also only have one charge, so those are not variable charge metals. But copper, gold down below, and to the right, tin and lead can have a variable charge. And so we can see from this chart that some transition metals can have a variable charge and some cannot. The ones that can have a variable charge are the ones that we will denote the charge with a Roman numeral in the parentheses. So let's see what we mean. For example, copper can either have a +1 charge, or a 1+ charge, we would say, or a 2+ charge. And the way that we write the names of each of those ions is by using the Roman numeral in parentheses. And I'm going to underline this here in blue because that's an important point for today. Okay, so the way that we would say this ion, right, name this ion, say it out loud, would be copper 1. And we write it with a Roman numeral 1 in parentheses. The way that we would say copper 2+ is just saying copper 2. And we would write it with a Roman numeral 2 in parentheses. All right. Another transition metal with a variable charge is lead. And lead can have either a 2+ charge or a 4+ charge. And we'll say lead 2 or lead 4. With either a 2 in a Roman numeral in parentheses or a Roman numeral 4 in parentheses, each denoting the charge of the variable charge metal. All right, so what happens when these ions link up, when these cations, right, these are, by the way, these are transition metals, so they're metals, and so they lose electrons and obtain a positive charge by losing a negative charge electron, okay? And so when they become ions, when they link up with a negatively charged ion, let's figure out how we name those compounds, and let's figure out how we write the chemical formulas for them, okay? So let's first start going from a name to a chemical formula. All right. So, for example, iron 3 iodide. By the way, when we write these names, there's no space in between the Roman numeral and the first cation name, but there is a space in between the cation name and the anion name. And by the way, I don't know if I mentioned last video, but the way that we always write the chemical formula for, or write the name for an ionic compound, we always put the cation first and then the anion. You might have noticed that that's what I was doing, but I don't know if I explicitly said that. It's always cation first, then anion. All right, so let's figure out then how we write the chemical formula. So from the name, we're going to write the formulas for the ions themselves. Iron has the element symbol of Fe, and it's got a 3+ charge, and we know that from the Roman numeral of 3. Iodide. All right, iodide is the anion form of which element? That's right, iodine, which is in group 7 right down here. And so remember that we figure out the charge on these non-metal anions by taking the group number and subtracting 8. So 7 minus 8 is -1, so it has a -1 charge. The way that we can also think of it is that the elements in this group right here gain 1 electron, right? They gain 1 electron, and when they do, they obtain the noble gas configuration of the of the noble gas right next to it. Okay, so by gaining 1 electron, iodide obtains a 1- charge and the electron configuration of the noble gas next to it, which is xenon. All right, so iodide has a 1- charge. So let's figure out, I'm going to write this a little darker. Let's figure out now, just like we did last time, now that we've written out the 2 ions, how many of each need to come together in the compound, right, to cancel out the charges and get an overall net charge of 0. So we have a +3, a 3+, and a 1-. So how many iodides total need to be in the compound to cancel out the 3+ charge? Right, there need to be 3 of them. Okay, those are those 3 I-. Let's again tally up the positive charge from the cations and the negative charge from the anions, right? Those cancel out to 0, right? And so now let's write the chemical formula for this compound. We're going to circle each ion to show the pieces that come together, right? This is the way that we are, by the way, from Johnstone's triangle last time, right? We are showing the symbolic representation of the chemical formula, or rather of this compound, when we write it out. So there is 1 iron 3, right? We just don't write the 1 there. It's implied. For every 1, 2, 3 iodides. So this is the chemical formula for iron 3 iodide. Let's do another example. How about lead 2, or rather lead 4, oxide. Lead 4 oxide. We're going to do the same thing. Let's write, just like we did last time with the main group metals, we're going to write the symbols for the ions with their charges. We know that lead, with this Roman numeral 4, has a charge of 4+. So Pb, 4+. And we look on the periodic table to figure out which charge oxide has. It comes from oxygen, right? Oxygen is in group 6A. So 6 minus 8 means it gets a 2- charge. We can also think of that as oxygen gains 2 electrons, and when it does, it obtains the electron configuration of the closest noble gas, which is neon. So gaining those 2 electrons gives it a 2- charge. Now we're going to figure out, in order to cancel out the overall charges, how many oxides we need for how many leads. Well, we have a 4+ and a 2-. So how many 2- do we need for the oxides to cancel out the 4+? We need 2 total, right? So we write those there. Just to be sure, we're making sure that the overall charges cancel. So we've got 4+ for the cation and 4- for the anions, right? That's a 0 net charge, all set. So now we know we can take the pieces, the ions together, and write the chemical formula with the proper ratio of cations to anions. So we've got 1 lead, right? And 1, 2 oxides. So that is our chemical formula. Let's see if we could do this with the quick trick that we learned last time. If we write the cation and the anion, can we take the superscript number into the subscript on the opposite ion to formulate the chemical formula? Yes, we can, right? When we take this 1 down after the iron, we just don't write the 1, we just know that it is implied. And when we take the 3 down into the subscript of the iodide, we get the same thing, right? So it's important to understand that this is why we can do this trick, but you are perfectly capable of doing this trick. You're perfectly, that's an option for you if you want to do that. Over here, just be careful though, right? If we do it for Pb, 4+, O2-, and if we're not aware of the actual overall ratio, you might be tempted to leave the subscripts unreduced, right? If we do this, the 2 would come down, and the 4 would come down after the oxygen, right, after the oxide. But we know that Pb2O4 is not the most reduced ratio of the ions in the compound. We know that PbO2 is. So just be careful that when you do, and if and when you do use this quick trick, that you are reducing to the lowest ratio. But we don't have to worry about that if we use this method up here. So it's up to you. All right, so that is how we go from the chemical, or rather from the name to the chemical formula. Let's look at how we do it in reverse. Chemical formula to the name. Okay, so this time it's a little more tricky and it takes a little more careful working out of a problem like this. Okay, so we're going to take some steps. Step number 1. We want to figure out the charge on the anion first. Okay. After we do that, that'll make it easier for us to figure out the charge on the cation, because remembering that the cations can have more than one charge. So which is it? We'll find out. So the second step would be to list all the components. I would say list all the pieces based off of the subscripts in the chemical formula. All right. And then the third step is we're going to find what the cation charge must equal in order to cancel out the anion charge. then finally we'll name it. We'll name the cation plus the anion. All right, so let's take a look at the first example. Let's name Cu3P. All right, so let's figure out the charge on the anion first. The anion is the second ion over here, P. Well, P is phosphorus, and it's in group 5A. So the charge on the nonmetals in group 5A, such as nitrogen and phosphorus, is going to be a 3- charge. 5 minus 8 is 3-. And the other way we can look at that is that phosphorus is 3 places away from argon, meaning that when it becomes an ion, it gains 1, 2, 3 electrons, getting a 3- charge. So let's write out the charge on phosphorus, 3-. Now we're going to list all the pieces based off of the subscripts, meaning there's 1, right? We just don't write it. So there's 1 P3-, and there's 3 copper ions. So let's write out all of those pieces. All right. Now we're going to figure out what the cation charge must equal to cancel out the anion charge. So we've got a 3-, and we've got 1, 2, 3 copper ions. So what must the charge on each copper 3, or rather, what must the charge on each copper be to cancel out the charge on the phosphorus? Right. Each must have a +1 or 1+ charge. All right. Now, to make sure, the total positive cation charge, right, cancels out the total negative anion charge. And that's that 0 net charge again, right? So now when we want to name the compound, we're going to name the cation plus the anion, right? Where there's not going to be any di or tri or anything. We're just going to say, okay, we know that now each cation is a copper 1. So we name this copper 1. And what do we call phosphorus once it becomes an ion? Phosphide, right? It's a main group nonmetal, and so it gets an IDE suffix. Okay, great. Let's do another example. What about FeS? And first of all, I should back up and make sure that you are always, when you're naming these compounds, right, that you are checking the chart over here to make sure that it is, in fact, a variable charge metal, right? Because not every metal in the transition metal block is a variable charge metal, as we just pointed out before. So is copper a transition metal with a variable charge? Yes, it is. It's in group 1B. It can have a 1+ or a 2+ charge. Is iron, in our current example, a variable charge metal? Yes, it is. In group 8B, it can have a 2+ or a 3+ charge. So it's up to us to figure out which one it is. And so let's find out. Using the steps that we have written, we're going to figure out the charge on the anion first. So sulfur, right? That's the second piece. That's the anion, right? Sulfur is in group 6A. 6 minus 8 is a 2- charge. Another way of looking at it again is that sulfur gains 1, 2 electrons to become an ion, and when it does, it has the electron configuration of argon. All right, so gaining 2 electrons gives sulfur a 2- charge. So let's write that out. And then we're going to write out all the pieces. Let's draw the pieces based off of the subscript. So here we have a 1-to-1. Right? And so these are all the pieces. We've got a sulfur 2-, right? So now let's figure out what the charge on the cation must be to cancel out the charge on the anion. If we've just got a 1-to-1 relationship, the charge on the iron must be 2+. That's right. 2+ charge. All right. So that's a correct charge that we figured out for iron here, because the net charge is 0. And let's name this compound iron with the charge in parentheses of that variable charge metal, iron 2 sulfide. Remembering that there's no space here, but there is a space here. All lowercase. Right? Oh yeah, sulfide, right? This is sulfur. The suffix changes to IDE for this main group nonmetal anion. So sulfide. Iron 2 sulfide. Let's do a third example here. Let's name Cr2O3. Well, we first have to make sure that chromium is in fact a variable charge metal to see whether we do in fact have to put a Roman numeral after it. Chromium, yep, it is. It's in group 6b and it can either have a 2+ or a 3+ charge. So which is it? Well, if we look at the compound, right, the formula for this ionic compound, it's actually a little bit more obvious as to which charge chromium has in this compound, right? Because this 3, right, if we did the trick to write out this compound, this 3 would have come from this number up here, the charge for chromium, right? This little 2 down here would have come from the charge on oxide. So sometimes it's a little more unclear. But just to be sure, let's make sure that we take the steps that we did before to make sure that chromium is in fact chromium 3 that we would expect from the compound. All right, so we're going to figure out the charge on the oxide first. That's the anion. Oxide gets a 2- charge because it's in group 6A. Right? And chromium, let's figure out the charge on chromium. Now we're going to see the pieces, we're going to list all the pieces based off of the subscripts. So there are 3 O2 minuses. And there are 2 chromiums. Okay, now let's figure out what the cation charge must be in order to cancel out the anion charge. So we've got 3 2 minuses. So what's the total negative charge in this compound? Right, 6 minus, right? Negative 2 times 3 is negative 6. Now, then, since we have 2 chromiums from the subscripts, right, there's 2 of these chromiums, what must the charge on each chromium be to cancel out this 6 minus? Right, each should be a 3+. All right. So this does give a net charge of 0 for this compound, right? Now let's name it. We said that each chromium has a 3+ charge, and so this name, because chromium is a transition metal, we have to figure out which charge it has, and that means it has a 3 in Roman numeral in the parentheses, right? So chromium, and this is oxygen. Right, so oxygen is a nonmetal, so when it becomes an anion, we give it the name IDE, OXIDE. All right, so that is that practice for naming ionic compounds of transition metals with variable charge. I hope you liked it, and I hope that you check out, or rather I should say be sure to check out the concept check in this module. Thank you for watching.